Now is the second step. Second step, we have to consider the boundary conditions. In this question, we have this condition, okay, these two boundary conditions. So we will change using u equal to xt as well. Remember about the boundary conditions. In this case, the original function is u. In the bracket, we have x and t. Okay, so means in this boundary condition, the bracket here, the first value here is value for x. Okay, so here is t. Right hand side means it is the value for u. Okay, so now we change u as x multiplied with t. So I will let this form remain. So x in the bracket x, the value for small x we will take. Okay, so here the value for the small x is equal to 0. So means we have u replaced as x. X here is 0. X multiplied with t. So t still contains t. Okay, equal to 0. This is t, small t. Okay, so we will take the one that contains the value for its independent variables. So in this case, we will have x0 equal to 0. And then from the second boundary condition, here the value for small x is equal to 3. So means we will change, this is x in the bracket 3, t equals 0. Again, we take the one that contains its value. So we have x3 equal to 0. Okay, so now this is the new boundary condition. Okay, there are two boundary conditions that we have. The new one in terms of x. Okay, so from the first step and the second step, the first step we have the two ODEs. One is the ODE for x, another one is ODE for t. And from the second step, we have boundary conditions for x only. Okay, so we can proceed to the third step. Third step is solving the ODE. So it comes from the ODE that we have. We have ODE for x is x double prime minus lambda x equal to 0. This comes from the first step. And we have ODE for t is 1 over 4 t dt equal to lambda. Okay, and from the second step, we have the boundary condition for x. x0 equals 0 and x3 equal to 0. Okay, so here we have to solve the ODE. Okay, we have to solve equation for x and also equation for t. Okay, because our aim is to get the solution for u. Okay, the original equation that we have is u in terms of x and t. So our aim actually to get solution for u. And at the first step, we assume that the solution u is equal to x multiplied with t. So means that by solving equation for x, ODE for x here, we will able to get solution for x. Solving equation here, we able to get t. So multiply them. Finally, we will get solution for u. Okay, but here in this equation, there appear lambda constant. Okay, unknown constant. So there are three possibilities of that constant. It can be 0, it can be positive or negative. So for positive case, we will set lambda equal to positive p square. For lambda negative, we will set it as negative p square. So for this equation, we have to solve for these three cases. Okay, and later we will have three cases solution for u as well. Okay, so beginning from lambda equal to 0. So if lambda equal to 0, we solve the equation. So which equation usually we solve first? Okay, so if we see from what I list here, equation 40 does not contain any condition here. Okay, but equation for x, we have the condition. So two conditions for the second order ODE. I can say that this one have complete to get its particular solution, right? Solution without any constant. So we will solve equation for x first. Okay, so for x equation, when lambda equal to 0, it is become x double prime equal to 0. So here we can integrate twice. From here, integrate once. Integrate 0 becomes constant. We would like to have x, integrate once more. Integrate a with respect to x becomes ax plus constant. So ax plus b, c, or any constant actually you can use. Okay, we have the condition. The first condition is x at point 0 equals 0. So using this means the value for small x is 0, the value for capital X is 0. So substitute in here, you will have 0 equal b. And for the second condition, x3 equal to 0, we use 8. Okay, this means the value for small x is 3, the value for capital X is 0, so we substitute. Now it becomes 0 equal to 3a plus b. So previously we get already b equal to 0, so this is equal to 0. So we have this in which we will get a also equal to 0. So in this case, substituting a0, b0, we get the solution x equal to 0. Okay, remember I said earlier, our aim for each cases here, we would like to have a solution u. Okay, so now actually, since x equal to 0, we don't have to solve equation t. Okay, because our aim is to get u, where u is equal to x multiplied with t. So we know already x is 0, so we already get the solution is equal to 0. So I prefer to mark the solution for this case. So okay, you can mark for example u1 for the first case, okay, or whatever, equal to 0, because x is already 0, no need to solve equation t. Okay, so done with the first lambda. The second lambda is lambda equal to positive p square. Okay, so lambda equal to positive p square. We substitute into the ODE. So we have x double prime. We have minus or plus minus. Okay, we have minus. So minus p square x equals 0. So this is the second order ODE, homogeneous. You have to apply back the method for solving homogeneous second order ODE, beginning from the characteristic equation. This is m square minus p square equal to 0. The difference now is we don't have the value for this. Okay, this is a constant actually. So find the roots for m square equal to p square. So we have m equal to, here is the constant, so square root of p square is p, okay, plus minus p. So this is case 2 different value for the roots. Okay, the case m1 not equal to m2. So remember the form of solution. In this case, capital X as a function of small x. Okay, so we will have x capital is equal to, I prefer to use the different constant. Okay, so I will use c here, c exponent px, okay, plus d exponent negative px. So again, we have the condition, we can use it now. So the first condition, x0 equal to 0, so we have 0 here, we have 0 here, and here exponent 0 is equal to 1, so we have c plus d. And for the second condition, we have 0 equal to c exponent 3p plus d exponent negative 3p. So from here, we able to write d as minus c. So if I replace into this, I will get C exponent 3p plus exponent negative 3p is equal to 0. Sorry, negative. Okay, here should be minus. So we able to get the value for C here. Okay, so in this case actually C equal to 0 because these two exponent will never be 0, right? Okay, so C equal to 0. So due to this, D equal to negative C. So the value for D is also equal to 0. So if we substitute in here C0, D0, for the second case here, X is also equal to 0. Similar explanation as here, U equal to XT. So now I will mark the solution as U2 equal to X multiply with T. So X is 0. We have also 0 solution here. No need to solve equation for T for this.